Hello everyone! My name is Harlan Luther. For this video, our group will be presenting the topic Proving Triangle Congruence using Two-Column Proof. This is a fundamental concept in geometry that allows us to prove whether two triangles are congruent or identical. Firstly, let's define what congruent triangles are. Two triangles are congruent if their corresponding sides and angles are equal. This means that they are the exact same shape and size, just possibly flipped or rotated. So we have five triangle congruence postulates and theorems. The side-side-side or SSS postulate, the side-angle-side or SAS postulate, the angle-side-angle or ASA postulate, the angle-angle-side or AAS theorem, and the hypotenuse leg or HL theorem. So now we will use the two-column proof and the SSS postulate to prove that two triangles are congruent. So now let's start proving. Our task is to prove the congruence between triangle ACB and triangle DCB. From the given, we have AB is congruent to DB and C is the midpoint of AD. For the first statement, we can say that AB is congruent to DB and this data is given. Second, C is the midpoint of ED. Again, this is given. Based from our number 2 statement, we know that AC is congruent to CD as per the definition of a midpoint. So a midpoint divides a line segment into two equal parts. So AC and CD are congruent. For the number 4, of course, each triangle shares the side CB. And we can say that CB is congruent to itself. This is due to the reflexive property of equality, which states that a quantity is always equal to itself. If all these corresponding sides are congruent, finally, we can conclude that for number 5, triangle ACB is congruent to triangle DCB. We have proven that all the three corresponding sides of the two triangles are congruent. Therefore, triangles ACB and DCB must indeed be congruent by the SSS postulate. Remember, the order of our proof is crucial because each step builds on the previous one, guides us to our final conclusion. So, make sure you follow a logical progression when working through geometric proof. And now, I will give the virtual floor to the next presenters, Mr. Carlos Suralta, Ms. Erica Rose Marhades, and Ms. Rinilyn Obensa to prove triangle congruence using the two-column proof and the four remaining triangle congruence postulates and theorems.
Good day everyone. In this video, I will going to discuss it to you the proving triangle using two-column proof, which are the SAS or side angle side and angle side angle or ASA. So without further ado, let's get started. Proving side and angle side angle postulates using two-column proof. Side angle side congruent postulates, which means that if two sides and the included angle of one triangle are congruent to the two sides of the included angle of another triangle, which means that if two sides and the included angle of the two triangles are congruent, it considered as side angle side congruent postulates. As what you've shown to your screen, there are two triangles which are triangle ABC and triangle XYZ. In the picture, you will notice that the two sides of the two triangles are congruent. However, we can automatically say that it is congruent. All we need to do is to prove it by using two-column proof, if it is true or not. So, we will proceed to the next example. So in the next slide, I will discuss it to you that the side angle side using two-column proof. So this one. So proving triangle congruence using two-column proof. So we have this triangle A, B, C, D, and E. So by proving of this triangle, we can use the two-column proof. So our given is triangle A, D, and C is isosceles triangle. So this one, A, D, and C. So we all know that this is isosceles triangle. And then prove triangle ADC is congruent to triangle BCD. So this one, ADC and BCD. So our first statement here is angle A, E, and D is congruent to angle B, E, and C. So our reason for that is vertical angle, since they intersect to each other. So our second statement is DE is congruent to CE. So this one and this one is congruent to this angle. So our reason here is definition of isosceles triangle. So this is our given, right? So since this is isosceles, so our third statement is angle A, D, and E is congruent to angle B, C, and E. So our reason for that is definition of equals. Since this is equal and this one. So our fourth statement is angle A, D, and C minus angle E, D, and C is congruent to angle B, C, and D minus angle A, C, D. So, the reason for that is subtraction property. Since this one, if you minus this angle to this angle, it is congruent to this one. So since we said it that this is equal, so when you minus this one and this one to this one, it is congruent. So our fifth statement is triangle A, D, and E is congruent to triangle BCA. So our reason for that is angle side angle postulates. Since this is congruent and this is congruent. So since this is equal and this is equal, so we can consider that these two triangle, this and this triangle, their angles are equal. So our sixth statement is AD is congruent to BC. So since we said it that this is equal angle, so we can say it that this is corresponding parts of congruent triangles are congruent. Since this theorem states that if two or more triangles are congruent, then their corresponding angles and side are congruent as well. So this is congruent. So our next statement is angle A, D, and C is congruent to angle B, C, D. Since we said it already that this is equal, so we can say that this is equal to by the reason of sum of equals. So our next statement is DC is congruent to CD. So our reason for this is reflexive property. So our last statement is triangle A, D, and C is congruent to triangle B, C, and D. So our reason for that is side angle side congruent. Since This is congruent and this is congruent as well. So the next slide is angle side angle congruent postulates. Angle side angle congruent postulates means if two angles and the included side of one triangle are congruent to the angle and the included side of another triangle, which means that if the two angles and included side of a triangle are congruent, it considered as angle side angle congruent postulates. As what should be shown to your screen, there are two triangles which are triangle ABC and triangle EFG. In the picture, you will notice that the two angles of the two triangles are congruent. However, we can't definitely say that it is congruent. All we need to do is to prove it by using two-column proof, if it is true or not. So in the next slide, I have a example for you. So proving triangle congruence using two-column proof. So we have two triangles, triangle ABC and BCD. So the given is parallelogram ABCD. So we need to prove that AC is congruent to BD and CD is congruent to AB. So our first statement here is angle A, B, and C is congruent to angle D, C, and B. So the reasons is alternate interior angles. So our second statement is CB is congruent to BC. So our reason for that is reflexive angle. So since we said it that this is and this triangle and this triangle are congruent, so we can say that this is congruent by the use of reflexive angle. So our next statement is angle D, B, and C is congruent to angle D, C, and B. So our reason is alternate interior angles also. So our next statement is triangle A, B, and C is congruent to triangle D, C, B. So our reason is angle side angle congruent postulates. Since this angle and this angle are congruent, this is so-called acute angle. And this one is congruent as well. That's obtuse angle. So since this is we said it that this is equal and this is equal, so by the use of angle side angle postulates, we can consider this equal as well. So our next statement is CA is congruent to DB. So corresponding parts of congruent triangles are congruent. So that's the reason. Since this is congruent and this is congruent, so this is congruent as well. So next statement is AB and CD. So this is congruent also. Since this is congruent and this is congruent, so this is congruent as well. So here are another example. So we have there's two triangles. The triangle A, B, C, and E, F, and D. So the given is triangle ABC is a right triangle. So this one, ABC. And BC is congruent to FA and angle A is congruent to angle D. So we need to prove that BA is congruent to DA. So this one. So our first statement is angle A is congruent to angle D. So that's our given here. And BC is congruent to FA. So our next statement is angle B is equals to 90 degrees minus angle A is congruent to angle A is equals to 90 degrees. Since if this one we can form here a 90 degrees. So our reason for that is difference of equals. So angle B and angle A is congruent property. So our next statement is angle A, B, and C is congruent to triangle DAF. So our reason for that is angle side angle congruent postulates. Since here and here they have the same angle. So the next is BA and DA. So we have we can prove that this is corresponding parts of a congruent triangles are congruent. Since this theorem states that if two or more triangles are congruent, then their corresponding angles and the side are congruent as well. So this one.
Good day, everyone. So the topic that I will discuss today is proving triangle congruence using angle-angle side or AAS. Angle-angle side or AAS congruence theorem: if two angles and a non-included side in one triangle are congruent to two angles on the corresponding non-included side in another triangle, then the triangles are congruent. Example: if angle BEC is congruent to angle FEG and angle BCA is congruent to angle FGE and line segment AB is congruent to line segment EF, then triangle ABC is congruent to triangle AFG. So let's prove by using two-column proof. Given line segment MS is congruent to line segment RQ, and line segment MS is parallel to line segment RQ. Need to prove triangle MSP is congruent to triangle RQP. Statements. Number 1. Line segment MS is congruent to line segment RQ, and line segment MS is parallel to line segment RQ. Reasons given. 2. Angle SPM is congruent to angle QPR. Reasons: vertical angles are congruent. Number 3. Angle SMP is congruent to angle QRP. Reasons: alternate interior angle theorem. Number 4. Triangle MSP is congruent to triangle RQP. Reasons: AAS or angle-angle sides.
So good day everyone. So ang ako report is about proving hypotenuse leg postulate using two-column proof. So what is hypotenuse leg postulate for right triangles? So if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent. So it means if ang triangles kay congruent ang leg, which is ang iyang adjacent ug ang opposite side ug ang hypotenuse niya kay matawag ni nato siya og hypotenuse leg postulate. So nako examples diri. So ang kani is ang hypotenuse niya ug ang leg is congruent. So mao ni siya ang hypotenuse leg postulate. So pwede sad ta maka-prove og triangle congruence gamit ang hypotenuse leg postulate using two-column proof. So let's try to prove a triangle using two-column proof and gamitan nato ang postulate or the hypotenuse leg postulate as a reason. So, ang given is triangle ABC is an isosceles triangle and segment BD is perpendicular to segment AC at D. So, i-prove na to ang triangle ABD is congruent to triangle CBD. So, ang first statement nato is ang triangle ABC is an isosceles triangle. So, mao ni ang ato given. So, second statement is segment AB is congruent to segment CB. So, ang kani is based ni siya sa given, which is ang triangle ABC is an isosceles triangle. So, if we have isosceles triangle, so na duha ka side sa triangle is congruent. So, that's why we have this statement. So, nya kay isosceles man siya, so we can say nga ang reason is definition of isosceles triangle. So, ang third statement nato is segment BD is perpendicular to segment AC at D. So, mao ni ato ang given. So, ang fourth statement is angle ABD and angle CBD are right triangles. So, based gyapon ni siya sa given, which is ang segment BD is perpendicular to segment AC at D. So, og perpendicular ang triangles, so maka-form ni siya og right angles. So, perpendicular man ni ang triangle, so naka-form siya og duha ka right triangle. So, mao ni. So, ang reasons ani niya is definition of perpendicular lines. So, kay right angles man siya, so therefore maka-form ni og right triangles. So, ang fifth is triangle ABD and triangle CBD are right triangles. So, ang reason ani niya kay definition of right triangle. So, kay right angles man siya, so it means right triangles siya. So, makasulti na tawag right triangles if na ay right angles. So, next is we have segment BD is congruent to segment BD. So, since nag-share sila og common side, so makaingat ta ani nga ang kani nga statement is a reflexive property of congruence because of this mark. So maka-prove na ta nga ang triangle ABD is congruent to triangle CBD. So ang reasons is HL postulate or hypotenuse leg postulate. So as we can see nga ang leg og ang hypotenuse niya kay congruent. So that's why ang reason kay HL postulate or hypotenuse leg postulate.
So that's it, everyone. I hope that